So we've been able to generate the epipolar pairs, extract an elevation model. We loaded that up in Focus. We performed some edits to create a digital terrain model, which we could use to generate our orthos, or we could elect to use the existing SRTM elevation model that we have. So now we can move to the ortho generation step. So we can select all of our images that we want to ortho. We will browse to our DEM. So I'm actually going to use the terrain model which I created myself. And I'll move these over to the images to process. I'll pick a location to create all of these orthos. So I'm just going to create an ortho folder. And I'll just click on one of these and they should automatically all be pointing to that ortho folder which I just created. So this is where the orthos are going to get generated. And I'm going to go ahead and generate the orthos. Okay, so as you can see, it didn't take very long to produce all these orthos, less than 2 minutes. And I'm going to load those up in Focus to have a look. And I'll just zoom out. As you can see right now, the surrounding parts of the air photos are still contained in each ortho, which is fine. We're going to get rid of those during the mosaicing stage. And let's just have a look here and see how things look. So if I turn this image on and off, you can see the positional accuracy is quite good across multiple images here. This road feature and the racetrack really isn't moving around very much. Things are looking pretty good. So I'm going to close that down and we'll move on to the next step, which is to generate our mosaic. The way that I recommend doing this is to take advantage of the mosaic tool, which is available within Geomatica. It actually allows multiple users to work on the mosaic at the same time. They can lock different parts of it. Now, in order to do this, you'll have to exit out of Ortho Engine. So we won't be using Ortho Engine anymore. So we can save our project. And we'll go to where our our ortho images are on disk. So recall that we created these ortho images. And what we're going to use is actually some Python scripts. We've packaged some Python scripts in the Udemy package, but let me just show you here some of the key routines that we can run. So we have a series of algorithms. We have an algorithm called mosprep, which is mosaic preparation. And if I pull up the help on that and I navigate to Python, you can see that we have an explanation of what the mosaic preparation is all about. And at the bottom, we have a code snippet. So for most of our algorithms, we have these little Python code snippets. So I can copy that in. And once again, if you go to the scripts folder, you'll see that we actually have that set up. So what you'll need to do is to modify the script to work with your particular situation. So for example, this is where your ortho images are located on disk. This is the name of the file that you want to create. So typically we call it mosaic prep, and just the location where you want to save this file. The parameters can be looked, you can search up the parameters in our help documentation, but this is the no data value, the sort method, the normalization, and most importantly here is the bundle method for the color balancing. So this will allow you to use the dodging points, both the edge dodging and the floating dodging points. If we wanted to mask water or do other operations, we have the ability to do that here. Cut line method is minimum square difference. So as you can see, this is going to write the mosaic prep file in our mosaic folder. So let me just open that up. This is where the mosaic preparation files will get created. To execute the Python script, I can do it in many different ways. Probably the simplest way is to just double click the file and the Python interpreter will initiate the script and get everything going. So if I go to the folder where the scripts are located, I can simply double click the script and everything's going to run here. So there we go. That just took a few moments. And so now we can go back to the Geomatica toolbar and we can open up the mosaic tool. And what we can do is we can drag and drop that XML file into our mosaic tool, and it's going to load our project and display our images. So you can see that the color balancing has already been applied by default using the bundle method. Now, in order to in general achieve a good result with this tool, what we recommend doing is to select all of the images and then just visually maybe go to a bright area. So maybe you want to preserve some of the information here. So let's bring this down a little bit. So we're just enhancing the display at the moment, but we need to have the display look as nice as possible in terms of preserving our color balance overall. So that's looking like it's preserving most of the information content. There are some darker areas here, but in general I'm happy with the way this looks. I can always re-enhance it, but if you enhance too much, then you clip the data and you can't get that back. So let's leave it like that for now. This is an overexposed area which we can fix a little bit later. So that's kind of step number one. Step number two would be to just in general look at the images and see if there are any that are not well balanced compared to the others. So we can select an entire image. So for example, this middle one here. So let me turn on the cut lines once again. And I'll select this image. And what I can do is I can pull down the global controls for that image. So this will actually enhance the entire image all at the same time. So you can see that as I'm moving the slider up and down, this is enhancing the entire image. So maybe I need to bring that down a little bit, just that one image. And I'll do the same with this image. That was the area that was a little bit overexposed, so I'll bring this one down individually. So that's looking pretty good. This one maybe is a little bit dark along here, so let me bring the brightness up. So really what we're trying to do is we're trying to balance the images to each other visually as we're working here. This one's a little bit dark. Actually this one's fine, we just modified that one. So overall this looks pretty good. The next step will be to turn off the cut lines and look for obvious areas that have sharp seams. So you can see one right here. You can see there's a really sharp seam line here, or difference in terms of the color balancing between these two images. So let's turn the cut lines back on, and we can select this image. So this cut line, we can turn on the dodging points. So you can see here we have some dodging points that are automatically calculated using the bundle method.